Math 3 Lesson Summary Video. Sandcastles. This lesson is a solidify understanding task, which takes concepts developed previously and helps you formalize those ideas. The purpose of this lesson is to deepen your understanding of the volume formulas for rectangular prisms and right circular cylinders, and to examine the proportionality relationships of lengths, areas, and volumes when geometric figures are scaled up. We'll begin making sure that we have all of our vocabulary. This is a rectangular prism. All prisms are made up of two base shapes that are then connected, creating faces. In this case, there are four faces. The height of a prism is always the distance between the two bases. The bases, whatever shape they may be, are connected by rectangles. The faces are always rectangles. In a cylinder, it still has bases. It's just that its two bases are circles. And because it is a circle, our faces can't be rectangles. There are no distinct faces connecting them. There's just one rectangle connecting the circles wrapped around. Think about it as like a label on a can. And this is called the lateral area. You'll also see lateral area used to refer to all of the faces of a prism. But with a cylinder, it's more important because there is just one face wrapped all the way around it, that lateral area. There are several formulas that we are going to use throughout this unit dealing with our three-dimensional shapes. Let's start with volume for a prism. Notice that I also have cylinder in parentheses here. This formula, it's the same concept for both of these shapes. To find the volume of a prism or a cylinder, you have to take the area of the base and multiply it times the height. So here, capital B is the area of the base, and then height, we mentioned, for prisms and cylinders is the distance between the two bases. So if you take the area of the base, this works for any prism and even includes cylinders, because as long as you can find the area of that base shape, whatever polygon or circle that it happens to be, you find the area of that base and then multiply it by the height, the distance between the two bases. So in order to use the volume formula, we do want to make sure that we remember all of our little area formulas that we have for all of our two-dimensional shapes. Triangle, 1/2 base times height. Square is a side squared. Rectangle, length times width. Parallelogram, base times vertical height. Trapezoid, 1/2, base 1 plus base 2 times height. And circle, pi r squared. So it does require you to make sure that you go back and remember, but instead of trying to memorize what is a rectangular prism's volume, what is a pentagonal prism's volume, what is a triangular prism's volume, you just know all prisms and cylinders are the area of the base, whatever that shape is, times its height. Surface area, if you think about volume as how much space is in a three-dimensional shape, surface area is the two-dimensional part of that 3D shape. Many people like to think of a three-dimensional shape squished out, or if you tear it apart and lay it flat, that's called a net, and it's the surface area of the net. Some people like to think about if you took wrapping paper and actually wrapped your three-dimensional shape, how much wrapping paper would it take to wrap over it? But surface area is the area of all the bases and all the faces. So when in doubt, if you can't ever remember a formula for surface area, you can literally go face by face, base by base, and just find the areas of all of those two-dimensional shapes and add them up. That always works for finding surface area. However, for prisms and cylinders, you can go a little quicker if you know the area of your bases, which we need to know for volume anyway. And there's two of those bases, so 2 times the area of the base. And then to find the area of the faces, or the lateral area of the cylinder, if you take the perimeter of the base and multiply it times that height, that distance between the bases, that will give you the area of all of the faces at one time. And then if it's a circle, you just have the lateral area, the one face. So 2 times the area of the base plus the perimeter of the base times the height. In this case, though, perimeter, you know, for polygons, you just add all the sides of the shape to find the perimeter. We don't really talk about perimeters with circles. We call that circumference. So you also want to make sure that you remember your formula for circumference. So lots of things to go back and make sure that you access in your memory banks. One of the big things that we get out of going through this task is, as you're building the sandcastles and as you're finding areas and volumes that it asked you to find, and you're using all of the formulas that you've used before, it's wanting you to start to notice what happens if we scale up, if we times a shape by 2 or times a shape by 3, and what does that mean? So what happens to the perimeter and area of a shape as you scale its dimensions? So if I have a rectangle, it's got the length of L and a width of W. If I wanted to find its perimeter, I would have to have 2 L's and 2 W's, because I've got 2 widths and 2 lengths. So I get 2L plus 2W. If I wanted to find its volume, or its area, excuse me, I would just do length times width. So what happens to the rectangle if I double its width and its length? If I take the width and multiply it by 2 and the length and multiply by 2. So I'm scaling the shape up by 2. Well, I would still have to do 2 times the length plus 2 times the width. It's just that I have a length of 2L now and a width of 2W. So then if I factor out that 2, I have 2 times 2L plus 2W. So it looks like the original perimeter, 2L plus 2W, has now been doubled. So if I double the dimensions, then I double the perimeter. What happens to the area? Well, if I now have a length of 2L and a width of 2L, and I multiply those together, I get 4LW. Well, the original area was LW, so that means if I double the dimensions, the area actually gets multiplied by 4. So if I double the dimensions, the perimeter is also doubled. And if I double the dimensions, the area gets multiplied by 4. So the scale of 2 means the perimeter is multiplied by 2, and a scale of 2 means that the area gets multiplied by 4. Let's look and see what happens when we triple the dimensions instead of doubling the dimensions. So if I'm going to triple the dimensions, I still would do 2 times 3L, now that my length is times 3, and 2 times 3W. We know the commutative property says it doesn't matter what order we multiply those in, so we could say 3 times 2L plus 3 times 2W, and that would be the same thing. And then if we factor out that 3, we see that the original perimeter, 2L plus 2W, has been multiplied by 3. So if we triple the dimensions, we triple the perimeter. Let's see what happens with the area. If we take the 3L length and the 3W width, when we multiply it, we get 9 length times width. So if we triple the dimensions, the area gets multiplied by 9. So the big thing that we want to notice here is that if we scale our shape by 3, the perimeter gets multiplied by 3. If we scale our shape by 3, the area gets multiplied by 9. So notice that the relationship between scaling the perimeter and the area is the square of the scale. And that makes sense. Perimeter is one-dimensional. We just have length and width. Everything's being added. But in area, we're multiplying. So if I take that scale of 3 and I multiply it times that scale of 3, it ends up scaling it by 9. And that makes sense. Well, what does it do to volume? let's take a look and see what happens with volume. So this is a cylinder. So if we wanted to find its volume, we would have to do pi r squared times the height, because we said it's the area of the base. Pi r squared is the area of a circle, and then times its height. If we scaled the radius by 2 and the height by 2, so we've taken our dimensions and we've multiplied them by 2, we've scaled them by 2, what happens to the volume? So let's do our formula. So if I have pi r squared, but this time my r is 2r, and then my height is 2h, one of the things we have to remember is laws of exponents tells us that if you have an exponent outside of the parentheses, everything inside has to be squared, because we're doing 2r times 2r. So that actually becomes pi 4r squared. And then we have that 2h still there. If we take the 4 times the 2, we actually end up with 8. So the original volume, pi r squared, or pi r squared h, gets multiplied by 8. So if we scale the dimensions by 2, then the volume gets multiplied by 8. Let's look and see what happens when we scale our dimensions by 3. So again, we're going to put 3r in for r and 3h in for h. So when we square, we get 9r squared times 3h, which gives us 27 pi r squared h. So the original volume gets multiplied by 27. So if we scale dimensions, volume ends up getting cubed by that scale cubed. So we know perimeter is one-dimensional, so the scale stays the same. Area, we've taken something times something, so it's a squared dimension, and therefore that scale factor gets squared. And volume, because it's three-dimensional, we're going to multiply that dimension times 3 times, and so that scale factor ends up getting cubed.